All right, so in section 3.1, we're going to start off by identifying pairs of lines, and then we'll switch over to angles. So we're familiar with some of these. Notice they have kind of highlighted here parallel lines. We're going to also talk about skew lines, which is that part is probably new. I don't know that you've learned skew lines before. We'll also have perpendicular lines. I don't think that's highlighted in here, but we'll get to that. And then also parallel planes. So parallel lines you've heard of, skew lines you may not have. Both of them are pairs of lines that do not intersect. So if I put these two down, if I illustrate two lines with the pencil and pen, if they're at the same slope and they go on forever, they would never intersect. You know that those are parallel lines. But skew lines are also lines that never intersect, but we have to add in a third dimension. So to parallel lines, they both lie on the same plane, so we can put them in a two-dimensional figure. But with skew lines, I now enter a third dimension, and so they're kind of pointing different directions. They can kind of overlap like this, but one's higher than the other, so they don't actually, you can see that there, they don't actually touch each other. Those would be skew lines. Intersecting lines are lines that actually touch, and if they're perpendicular, they have to form a 90-degree angle. But if we elevate them so they don't actually overlap, but they'll never touch, that's skew. So you can look in this picture here. They kind of illustrate it. M and N are in the same plane, so we know that they're parallel. They use these little triangles on the lines to mark that they're parallel. Because that's something we shouldn't just assume. We shouldn't just say they look like they're parallel. We actually have to indicate it. So they're marked with the little arrow. Now M and K, so K is going up and down. It looks like it intersects line N, but it does not intersect line M. So they don't lie on the same plane. They're not coplanar, but they don't intersect. That makes them skew. Now planes can be parallel if they don't intersect. So we see plane T and plane U, one on top of the other, not touching each other. We kind of get the dashed line back here because we know that it's showing us it exists without actually intersecting. So those would be considered parallel planes. Parallel, we represent a lot of times with these two vertical lines, two vertical bars, and so T and U, they're saying they're parallel here. Line M and N are parallel. And then it says lines K and N. So K is the one going vertical, and then we've got N here. They are intersecting lines. And there is a plane that's not shown that contains them. So you could draw a plane here that hits both of those lines at the same time, travels at them. It kind of goes at an angle, but it is possible to do that. Okay, so let's take a look at this picture here now. We've got this box, and we're going to answer some questions based off of this box. We're going to assume that these edges or these lines would continue on forever. We can't, of course, show that very well, so we show it with a box. So in part A, we're going to list all of the lines that are parallel to line CD, but they also have to contain point A. So parallel to CD has to go the same direction as CD. So EF is parallel to CD, but it says to contain point A, so we can't use A or EF here. Same thing with HG. HG goes the same direction, same slope as CD, so it's parallel, but it doesn't contain A. The only one that contains A that's parallel is line AB. So that would be the answer to that question. It's a line, it's not a segment, so I put my double arrowhead above it. But line AB would be parallel to CD. They're both on the top of the box, they're in the same plane. They won't intersect. Part B says line skew to CD. So it's not in the same plane, but not intersecting. So not parallel, but it still can't intersect, and it's got to go through point A. So here's our CD still. So AH would never intersect it, so that would be skew, but it's not the only one. So I've got multiple answers to this problem, I believe. AG hits point A, and it's never going to hit that line, so AG would also be skew. Are there any others? There actually are. They're not drawn in this picture, and you have to understand lines are not always drawn. Doesn't mean it doesn't exist. But I have point A and I have point E. I could connect those two with a line, and that line will not intersect CD. It's not in the same plane. So that also, AE is also skew. And then with the same logic, I can connect A and F and kind of go diagonally through the box. hit those two, and it's not going to connect to CD, so AF would also be a skew line. And I think those are the only ones that go through A, because I can't connect A and D. A and D intersects the line, so it's not skew. AC would intersect, and AB we already said is parallel. So those are the only four that are left then. Okay, next says lines perpendicular to CD, and they contain point A. So if I'm at point A, and I want to be perpendicular, it does have to intersect it and make a right angle. And I see if I travel down D from A to D, we see this little box here that shows us that it is in fact 90 degrees. So line AD is perpendicular. Let's see if there are any others. The only other point on that line is C. If I connected A to C, they would intersect, but it would not make a right angle. So AC is not perpendicular. So AD is the only one for part C. Part D says a plane parallel to plane EFG. Now we got to remember from chapter 1, when we name a plane, we have to use 3 letters, just like they did, EFG. So we're going to be giving our answer with 3 letters as well. It does say it has to contain point A, parallel to EFG. So I'm going to figure out what plane EFG is. So locate point E in that front lower corner, lower left corner, and then F, so that's in the back lower left corner, and then G is the back lower right corner, so EFG. So they're talking about a plane that hits all 3 of those. So the only, if we're talking about the front of the box, the back, the left, the right, the top, the bottom, the only plane that hits all 3 of those points is the bottom. So when they say plane EFG, they're talking about the bottom of the box. And we want to be parallel to that and through point A. So we can't intersect that plane, so if you're thinking about the bottom of the box, the top of the box is the one that doesn't intersect it. So we're going to try to name this plane up top, that's the top. It does say to include point A, so I'm going to have to use that in my answer. So I'm going to write plane, and I'll start with the letter A. I have to use 3 letters, so there's a B, a C, and a D left. You're going to pick 2 of them. Doesn't matter which 2, and it doesn't matter the order. So maybe I would go B and C. It would be perfectly fine to use B and D, or C and D, and it would also be fine to switch the order of the letters. But I've got to pick 3 of the letters on that top side. Okay, so that's a short discussion about identifying pairs of lines, and we also have the parallel planes in that as well. But then we get into pairs of angles, identifying pairs of angles. Before I get into this set down here, I'm going to draw a similar picture kind of off to the side. So you see I have 2 lines. They're not necessarily parallel. They are in the same plane. Now these would probably intersect later on in the chapter. Next section we'll get into ones that are specifically parallel, but right now we're just identifying, so we don't really care if they're parallel. But we do have a line that intersects both of them. And that line that intersects both of them has a name. It's named over here. It says a transversal is a line that intersects 2 or more coplanar lines at different points. So it intersects it at this point, intersects it at this point. So that line that I drew in last, that was the transversal. It has a name. Now at those 2 intersection points, we created a bunch of angles. At this top intersection point, when it intersected that top line, 4 angles were formed. So I'm going to go ahead and name the one in the upper left, I'll name angle 1, and then I'll go to the right, I'll name that angle 2. If I go lower left, I'll name it angle 3, and lower right, I'll name it angle 4. Now, every picture we might name them differently, so it's not like that's a rule that it has to be 1 in that spot, 2 in that spot, etc. But then we also, that transversal intersected another line, created 4 more angles, so I'm going to name them as well. 5, 6, 7, and 8. I kind of went in the same pattern. We don't always follow that same pattern. But that picture is kind of what we're referencing when we look down here at the key concept. This key concept here, this box, is probably worth starring or highlighting. These terms are going to be extremely important terms throughout the chapter. The next couple of sections included. So we'll keep coming back to these terms. And so they're highlighted here, corresponding angles, alternate interior angles, as well as alternate exterior angles, and consecutive interior angles. So we've got a few words that show up over and over. Corresponding is kind of its own animal, I guess, but the other ones we see alternate interior, alternate exterior, consecutive interior. So we see alternate and consecutive contrasting each other, and interior and exterior contrasting each other. So it's probably worth having an idea what those mean. So if we see alternate, or like alternate, it just means different sides of the transversal. Maybe to the left and to the right, or top and bottom, but different sides of the transversal is what that's going to mean, or alternating sides. Consecutive, we only see that in the last one, but consecutive is going to be same side of the transversal. And then we also see interior versus exterior. So interior, just like if you have an interior decorator, they're decorating the inside of the house. Interior is the inside of these two lines, so it's between the lines. So you're ignoring the transversal right now, but you're looking between the lines. So in this picture, 3, 4, 5, and 6, those are the angles that are between the lines. Those are your interior angles. So between the two lines. And I say two lines as opposed to the transversal. And so then exterior, like someday, if you've got your own house, years down the road, and you've got to have someone come and paint the exterior of your house, they're painting the outside of your house. So when we're talking about exterior angles, we're talking about angles that are outside of the two lines. So 1 and 2 and 7 and 8, they're not between the lines, they're outside of them. So that's the exterior angle we're talking about. Outside the two lines. That's kind of what those words mean. Now let's go and apply them. Okay, so let's come back to the first one, corresponding. I did not just define corresponding, but corresponding basically means the same position. And so they show in this picture 2 and 6 as an example. So I would describe angle 2 as being to the upper right of that intersection. Where those two lines intersect, the transversal and the top line intersect, they create 4 angles. Angle 2 is in the upper right-hand position. So then we go to the other intersection, where the transversal intersects the other line, go to the exact same position. So upper right, that's angle 6. So 2 and 6 are both in corresponding positions, so they're corresponding angles. But they're not the only ones. So I could also, let's list the other pairs down here. Angle, or if I look at this picture up here, we see them all labeled. Angle 1 is in the upper left. Angle 5 is in the upper left. So 1 and 5, they're both in the same positions. So I could also list angle 1 and 5 as another pair of corresponding angles. They already gave us 2 and 6. 3. I could describe 3 as being in the lower left position at that intersection. So if I go to the other intersection, go to the lower left, that's 7. 3 and 7 are in the same position, so we would say that they are corresponding angles. And then lastly, we've got angle 4. It's in the lower right. If you go to the other intersection, angle 8 is in the lower right. So 4 and 8, they're in the same positions. That makes them corresponding angles. Then they get into these other words, alternate and interior. So alternate, we said different sides of the transversal. Interior is angles between the lines. So interior, if you wanted to actually connect your lines like this, if it helps you, you could pretend this is a house. And interior is inside. So we're only looking, you know, the angles that are options are 3, 4, 5, and 6. But if we want to be on differing sides, they give 4 and 5 as an example. So 4 is up at the top intersection point. And then we go to the bottom intersection point, have to have another interior angle, but has to be on the alternate or the opposite side. So that would be angle 4. 4 and 5 are opposite sides of the transversal, both in between the angles. We can't have 3 and 4 because they're at the same intersection point. So it's always got to be one point at the top, one point at each, one angle at each intersection point. So 4 and 5 was a pair. So then our other option, 3 is also interior. It's alternate interior. You have to switch sides when you go to the other intersection. You end up with 6. So 3 and 6 were the other choices. That's the other pair of alternate interior. And that's it. There's only 2 pairs of alternate interior. Then we go to alternate exterior next. So opposite sides, 1 at each intersection point, but now they're exterior, so they're outside the house. So once again, if we thought of this as a house, these were our interior angles, 1, 2, 7, 8. Those are our exterior angles. So we grab one angle from the top intersection point, so they grabbed angle 1. That's to the left of the transversal. So when I go down to the other intersection, I have to be exterior, and I go to the other side, the alternate side, the 8. 1 and 8 are a pair of alternate interior angles. But they're not the only pair. 2 is also exterior. So if I go down to the other intersection, go exterior, switch sides, I get 7. So angle 2 and 7 are alternate exterior angles. And then lastly, you'll notice that they talk about consecutive interior. They do not talk about consecutive exterior. You could. Our textbook does not. So we're just going to talk about consecutive interior. So consecutive is same side of the transversal, and they're interior. So think about your house again. We're inside the house, so we've got 3, 4, 5, and 6 as options. So they went ahead and used 3. That's to the left of the transversal, and we want to be on the same side. So we stay to the left, just go to the other intersection point. So 5 is also to the left. So 3 and 5 is the pair that they give. But then if we come over to the other picture, or our picture up here, that wasn't the only pair. If we go to the top intersection, 4 is an interior, and if I stay on the same side, 6 would be its pair. So 4 and 6 are the other pair of consecutive interior angles. Okay, so now we go down to this example down here. This will finish out our notes. They give an entire picture. But they've arranged it differently, so that the transversal is now kind of going, it's not exactly horizontal, but it's closer to horizontal than before. So it's a little different picture. We have to list all of the pairs, not just one of each kind. So corresponding, same position. So I would probably start at the first intersection, that's the left one. So pick one of the angles. I could pick angle 1. So now I have to go to the other intersection point and find the one that's in the same position. So angle 1 I would have described as the upper left corner. So the upper left corner here, that would be angle 5. Angle 2 is in the upper right position, so is angle 6. So they're a pair of corresponding angles. 3 is lower left. 7 is also lower left. So they're corresponding. And then go to angle 4 yet, it's lower right, so is 8. So 4 and 8 are a pair of corresponding angles. So those are all of the pairs of corresponding angles in that particular picture. For B, they ask for alternate interior. So draw your house here, that might be helpful. So the interior angles here we're looking at are 2, 4, 5, and 7. Those are the interior angles, the only ones inside the house. So at the first intersection point, I could pick angle 2. And I see that I would describe that as above the transversal. So now I go to the other intersection point, and I have to go below the transversal. So that would be 7. So 2 and 7 are a pair of alternate interior angles. At that first intersection point, I could have also picked angle 4. And that would give me a different pair. So now 4 is below the transversal. So go to the other intersection point and go above. That puts me at 5. So 4 and 5 are alternate interior angles in that picture. C says alternate exterior. So exterior angles. So now outside of the house. So we're looking at angles 1, 3, 6, and 8 are the exterior angles. But I want to go on alternate sides. So if I go to the first intersection point, I might choose angle 1 first. So if I want to alternate exterior, I go to the other point, has to be exterior, so 6 or 8, but it's got to be on the other side, so it's got to be below the transversal, so I would put it at angle 8. And then I could have also chose angle 3 at that first intersection. So then its alternate exterior have to be above the transversal, so angle 6. And then lastly, we're talking about consecutive interior. So we go back to inside of our house. So 2, 4, 5, and 7 are the angles that we're looking at. Consecutive means the same side. So if I choose angle 2, we see that's above the transversal. So we stay above the transversal when we go to the other intersection. That puts us at angle 5, because we had to stay interior. And then I could have also chosen angle 4. So stay interior, go to the other intersection, the same side. That puts us at angle 7. So 4 and 7 are a pair of consecutive interior angles.